Last week you wrote a card and it had all the formulas on it. It had sum and difference formulas, double angle formulas, power reducing, half angle formulas, product to sum and sum to product. Okay, so this is my note card. This is what we're using. All right, we are doing 5.4. Okay, so my plan is to teach Monday, Tuesday, and Wednesday, and maybe you work on Thursday. I'm not really sure. I just do what? Yeah, I'm not going to work a lot on Tuesday. You're right. So Monday, Wednesday, and Thursday, we might test on Friday, but I'm not sure. We're going to see. This is really not that bad, okay? This is really not that bad. All right, so here we go. First of all, we're going to use these formulas. But let's just do one, okay? So number one, find the exact. What is the word exact telling you?
Not calculator.
Not to use a calculator. I want the exact value. You're not using a calculator rounding something off. Okay? So, pardon me. Find the exact value of the cosine of 75 degrees. No calculator. So what's the first thing that pops in your head?
Look at the thing.
No. Unit circle. Okay. So what about the 75?
Well,
Yeah, that's not a special one. Okay? That's not a special one. So let's talk about the special ones that we can use. Okay? The first ones are going to be the quadrant angles. 0 degrees, 90 degrees. What's the next one? 180 degrees.
225.
What? 270.
Wait,
And then 360, which is 0. Do you agree? Okay, so those are all the quadrant angles, Colton. Keep up. Quadrant angles. All right, so now let's talk about, now look, do you agree that I could just say 0 and 90 and all their multiples?
Yeah.
Because, look, 90 times 2 is 180, 90 times 3 is 270. Do you understand what I'm saying? That's going to be important, multiples, because that does come into play. All right, so since we're doing that, let's only look at the degrees, okay, in the first quadrant. So, the special ones that are not there, they're in the first quadrant.
30.
30.
45.
45 and
60.
Is everybody with me? Okay, let's do them in radians also, okay? So, these are degrees.
Oh, yeah, are we writing this?
Okay, and these are radians. So what is 0 degrees in radians?
0.
What about 90? What about 180? Now, do you see that? Do you see those multiples? Pi over 2 times 2. That's 2 pi over 2. That's pi. Pi over 2 times 3. 3 pi over 2. Are you with me? Yes? The next one is pi over 2 times 4. Well, that's 2 pi. That's the same thing as 0. Okay? All right, what is 30 in radians?
Pi over 6.
Pi over 6. What about 45? What about pi, 60? Thank you. Okay, now think about this, okay? Put pi over 6 in the second quadrant, and what is it? 5 pi over 6, okay? 5 pi over 6. What is 5 times 30?
150.
150. Where is 150? 30 degrees off of 180.
Oh,
That's reference angle. Are you with me? I ought to be connecting some dots here, people. Okay? Put pi over 4 in the second quadrant.
3 pi over 4.
3 pi over 4. 3 times 45,
135.
135. Guess how far off 180 135 is?
45.
45.
Oh my goodness.
Okay? This is 2 pi over 3. 2 pi's over 3. 2 60s. 2 times 60 is 120. Guess how far off 180 120 is?
60.
60.
Miss Davis,
Okay.
why did you tell us this sooner?
Well, because even if I told you sooner, would you have gotten it?
Yes.
No.
I would have.
Okay, let's put this, watch, I'm gonna go one step farther and then I'm gonna quit. Put this in the third quadrant.
Got it.
7 pi over 6. What's 7 times 30?
21.
210, right? How far is 210 from 180? 30 degrees. That's why he is his reference angle. Okay? This is 5 pi over 4. I'm glad that light bulb came up.
5
Okay.
power.
5 pi, 5 times 45,
That'd be
225.
Yeah.
He's 45 away from 180. This is 4 pi over 3. 4 times 60 is 240. 240 is 60 away from 180. Okay? So everybody understand all that? Those are all multiples. Okay, so those are the ones that I can use. All right, so I can't find the cosine of 75 without a calculator, people. All right? Because he's not special. Special angles are 0, 90, and any multiple of 90, 30, 60, and 45, and any multiple of those. All right? If it's not one of those, I can't find it.
Until
today.
That's right. Until now. So let's just do sum and difference. Can you find a sum or a difference that adds or subtracts to be 75?
Yeah.
Using any of these or their multiples.
30 and 45.
30 and 45. So do you agree that this is the same thing as the cosine of 30 plus 45? Does everybody understand?
No.
What is 30 plus 45? 75. So this is the cosine of 75 written in a different way. Now let me ask this question. Can I distribute this cosine and just say, oh, that's the cosine of 30 plus the
No.
cosine of 45? People, if you could do that, you wouldn't need these formulas. Okay? You wouldn't need these formulas at all. I'm not asking you to memorize these formulas. I'm letting you use a formula card. Okay? When will you see these again? If you
Yes,
take
Friday.
calculus. If you take calculus, you will see these in calculus. Okay? If you don't go above pre-cal, then this would be pre-cal would be the only place you saw it. All right. If you took pre-cal in college, it would depend on the teacher whether they made you memorize these formulas or not. Okay? I'm not making you memorize.
Wait,
So
Mr.
we use.
So, I'm going to try to find a formula that looks like this. Cosine of something plus something.
The third one.
You got it? All right. Cosine of u plus v. Has everybody got it? There it is right there. U is 30 and v is 45.
Oh, I got that, yeah.
So, it's going to be cosine of u, cosine of v, minus sine u, sine v.
Whoa.
That's what we're rewriting it as. Okay? So, cosine of what?
30.
30. Cosine of 45. Minus. I'm following this formula card, guys. I don't know this. I'm following this card. Cosine of the first, cosine of the second, minus sine of the first, sine of 30, sine of the second, sine of 45. Okay, so now we gotta pull out those little memory skills. We're on the unit circle. Are you with me? Is everybody caught up? Okay, so we're on the unit circle. Cosine is the x, right? So at 30, who's the x value at 30?
1/2.
Square root of 3 over 2.
Square root of 3 over 2.
I knew it was one of them. I had a 50-50 shot.
Yeah, well, you lost that bet. All right, square root of 3 over 2 times, what's the cosine of 45?
Square
Power
root of 2
two.
over 2.
Square root of 2 over 2.
No.
It can't be an angle. Square root of 2 over 2. You could write it as 1 over square root of 2. I'll go over here on the side and do that one. I'll give you, it's, okay, anyway, we'll talk about it in a minute. Minus, what's the sine of 30? Y'all, if the cosine of 30 is the square root of 3 over 2, what's the sine?
1/2.
There you go.
I got that one.
Now it's your turn. And the sine of 45?
Square root of 2 over 2.
Yeah, those are the same. Those are co-functions of complements, and they are congruent. square root of 2 over 2. How do you multiply fractions?
Top, bottom times bottom.
So, square root of 3 times square root of 2?
Square root of 5.
What?
Square root of six.
Oh,
3 times 2
My
used to be
fault.
6 back in the olden days.
yeah,
What is 2
now
times 2?
4.
things have changed these days.
Can I reduce that 6 and that 4?
No.
Why?
No, because one's under the.
Yeah, he's in the house and he's outside the house. They cannot play together. This one, top times top, square root of 2.
Over 4.
2 times 2 is 4. Do these have the common denominator?
Yes.
So I'm going to write them together. The square root of 6 minus the square root of 2, all over 4. And like you said, you can't reduce that, so don't be. Can't collect those, they're not like terms. Okay? Now, I'm just going to go over here for a second and just show you what it looks like if you wrote this as 1 over the square root of 2. Okay? This would be the square root of 3 over 2 times 1 over square root of 2. Are you with me?
Oh, then you'd have to do the
Minus,
six
no,
whole.
wait. 1/2 times 1 over square root of 2. All right, top times top
Right
over 2 square root of 2. Minus, top times top, bottom times bottom, 2 square root of 2. Are these the same?
there. Yes.
So I put them over one denominator. Can I leave a radical in the denominator?
No.
That would've been hard.
What? Can I leave a radical in the
Yes.
denominator and trig?
Yeah.
Yes, it's legal. You can leave a radical in the denominator and trig. If you wanted to rationalize it, which means get rid of the radical off the denominator, you would multiply the bottom by the square root of 2. What's the square root of 2 times square root of 2?
Square root is
2.
2. What's 2 times 2? This 2 out here.
Four.
So there's my 4 on the bottom. Okay? Will you multiply this top by the square root of 2? The whole thing? What's the square root of 3 times the square root of 2?
Square root of 6.
And what's 1 times square root of 2?
minus square root
So
of
on the
2.
square root of 6, you don't take out the 2 square root of
That's not, no, that would have to be
No,
4.
no.
That's okay, that's okay. Alright, so these things right here are equivalent. They're the same thing, guys. Okay? Now listen, probably not going to let you use a calculator, but I just want to show you that while you're doing your homework and stuff, you can check these on a calculator. Okay? So, first thing I'm going to make sure I'm in degrees. Okay? And then I'm going to say the cosine of 75. So there it is, that big nasty decimal. Alright, and then I'm going to check this guy right here. I'm not going to put it in as a fraction. I don't really know. I could make it go as a decimal if I wanted to. So if you wanted to put it in as a fraction, you could do that and then maybe, I don't know. Yeah, go to math and it'll change it to a decimal for you. I'm not going to do it that way. I'm just going to do it in parentheses. The square root of 6, get outside, minus the square root of 2, get outside, close the parentheses. I want all of that divided by 4. You do have to put that in parentheses if you're doing it this way, not using the fraction button, because you want the whole top divided by 4. It should be the same, and it is. So, ding, 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 we won.
So, why do I have to write it out as that when if I put it in a calculator we know?
Because it said find the exact value, and that is not an exact value. And it will give you 0 credit.
But is there questions that are not the exact value?
Nope.
Okay.
That's the whole point of all these little formulas.
Great.
Okay? Alright, let's move on, people. Let's move on. Example 2. Are y'all ready? Y'all, this is simply can you plug stuff in a formula, okay, and make it work. I am going to make this one a little more difficult.
Of course.
Sine pi over 12.
Can I have my rock back in? Yeah.
Okay? Sine of pi over 12. Now, first of all, why is this one more difficult?
On the exact.
Yeah, it's not in degrees, so that's making you use radians. Second of all, it's fractions, and we all know how good you are at those. Okay? So we're going to practice with them.
It's not
All
our
right.
fault. It's
Now.
school board. When we were younger, they were like, y'all don't need to know this.
Oh, please.
I'm telling
They didn't
you.
teach us cursive.
Same with
They didn't teach us cursive person
They
either,
skipped
and now I
us.
can't read.
Stop blaming other people for your life,
US
okay?
government.
I
Okay,
skipped
well,
the next one. I can't
Alright.
read.
Hey, we're trying to record and you are distracting. Alright, so first of all, I can either add or subtract to get this 1 pi over 12. Okay? Add or subtract to get this 1 pi over 12. Now, do you see two possibilities to give me a denominator of 12?
Yes.
Tell me what they are.
I see pi over 2 times pi over 6. I also
Okay,
see
the 6 and the 2
Yeah.
or the
pi over 4.
3 and the
pi
4.
over 3.
Okay, so let me ask you a question. Between 6 and 2, what's the least common denominator between 2 and 6?
2.
6.
Oh, 6, yes.
So that's not it, people.
12.
Okay? What about 4 and 3?
12.
That is 12. Okay? So let's make both of these have a common denominator of 12. Okay? What would I multiply this guy by?
3.
3. So do you agree that he's going to be 3 pi over 4? Pardon me.
3 pi
I
over
did that this
12?
morning. Yes, 3 pi over 12. Thought I'd be better this afternoon, but I'm not. 3 pi over 12. What would this guy be?
4 pi over 12.
4 pi over 12. Do those subtract to give you 1 pi?
No, yeah.
Yeah, we just flip them around. Do you agree with that? I can say 4 pi over 12 minus 3 pi over 12, and that will give me 1 pi over 12. All right, so let's do it.
Wait.
This is really the sign of, what is 4 pi over 12? What is 4 pi over 12?
Pi over 3.
Pi over 3. Minus, what is 3 pi over 12?
Pi over 4.
Yeah,
Wait.
I'm sorry. I wrote a 2 and I didn't write a 3. Sorry, been on vacation. Trying to get back in the groove. All right, so is everybody okay? All right, so I got pi over 3 minus pi over 4. That is pi over 12. All right, so can you find a formula that matches this? I want the sign of something minus something.
Got it.
You got it?
There you go.
It's the second one.
It's the second one. So it's going to be the sine of the first, cosine of the second, minus cosine of the first, sine of the second. Are you with me?
Yes, but I have a question.
Yes.
Why didn't we use pi over 2 and pi over 6?
The least common multiple between 2 and 6 is 6.
I know, but we could just make it 12. Or
Well, you
does it
could,
have-
but it's not going to give you a 1 in between it.
So it has to be the
When you
least common
subtract them.
multiple?
No. You're just
So-
going to have to figure it out. Okay? You're
Yeah,
just
you-
going to have to figure it out. You want to try a 6 and a 2?
No, because I know it
Okay,
would be
watch.
wrong.
Let's do this one. That would be 2 pi over 12. Do you agree?
It'd be 4.
2 pi over 12. This would be 2 pi over 12. What would this be?
6 pi.
6 pi over 12. Do those subtract to be a 1?
No. They add to be 8.
But that doesn't help me. Okay? So, okay, so here's what Jonathan's doing. Jonathan is kind of cheating, okay?
Not surprised.
Cheater.
No, okay, so
Pretty
here's what you,
superior.
look, listen to me. Let me tell you something. If you look at this and you're on a test and you tried some of them and you can't make it work, what should you do with this guy right here?
Look at your partner.
Convert it into degrees, and then you can bust it out and find it really easy, okay? Then once you convert it to degrees, put it back into radians so nobody knows you did it that way. You understand? So, we're fixing to follow this formula right here. Sine of the first, cosine of the second, minus cosine of the first, sine of the second. So, Eli, are you taking notes?
Yes.
Sine of what?
Pi over 3.
Pi over 3. Thank you, Sean, for helping him out because he was lost. Cosine of the second, pi over 4. Minus cosine of the first, pi over 3. Sine of the second, pi over 4. Okay? Now we can do all these, right?
For example, pi over 4 is the do we use a new
Is pi over 4 is what?
Good question, because it's minus and.
Okay, no, y'all look, that's just the formula. That's the formula. Don't look at that as a negative angle. Don't pull that negative angle down here. Just follow the formula, okay? Follow the formula. All right, So here we go. What is the sine of pi over 3?
Square root of 3 over.
Yes?
Wait a second.
That's
Is it,
60, and sine is y. What's the y value at 60? Square root of 3 over 2.
wouldn't it be pi over 4? Wait a second.
No, use your card. What's the cosine of pi over 4?
Square root of 2 over 2.
Square root of 2 over 2. Minus. What's the cosine? Now look at the relationship between these two things. 1 half. Times the sine of pi over 4. So top times top, bottom times bottom. What's this? Square root of 6 over 4. Minus, what's this? So I got the square root of 6 minus the square root of 2 over 4. Notice anything about it?
It's the same thing as the other
It's the
one?
same thing. Anybody know why?
Because it's
Because
the
we
same
use the
formula.
same
Use 34.
thing.
Let's see what pi over 12 is.
Oh,
Okay,
it's-
this is a
it's
cosine.
It's 75 degrees.
No, listen, it's not.
15 degrees.
It is. They are co-functions of complements. 75 and 15 are complements, and they have to be congruent. Co-functions of complements. Here's what that means, guys.
9 degrees.
Shh. That means that the sine of 60 is the same thing as the cosine of 30. It means that the sine of 30 is the same thing as the cosine of 60. It means that the sine of 45 is equal to the cosine of 45. Okay? If the angles make 90, then the co-functions are complement, are congruent. Like sine and cosine, tangent and cotangent, secant and cosecant. Okay? That's what that rule, we learned that like the first 2 weeks of school or something. But we've seen it come up several times. All right, here's the next one. This one's a little bit different. You ready? Example 3. Find sine u plus v given the sine of u is equal to 4/5 and u is greater than 0 and less than pi over 2. What does that tell you?
It's in the first quadrant.
It's in the first quadrant, okay? And the cosine of v is equal to negative 12/13. Now, what do you know about him? Where is he not?
First.
First or fourth, right? He has to be in the second and third. So the cosine of v is equal to negative 12/13, and v is greater than pi over 2 and less than pi. So where is he?
Second.
Okay, so let's talk about this first guy. All right, this first guy you said was in quadrant 1. So I'm going to draw a picture of him. Where am I going to put him?
First.
In quadrant 1, people. He's U. His sine is 4/5. Do you know where those go? Sine is y over r or opposite over hypotenuse. What's the side?
3.
3. That's a Pythagorean triple. Be careful and don't let them trick you. Will they try to trick you with the Pythagorean triple?
Oh, yeah.
Yeah, they'll put a 5 and a 3 on those legs, and your brain will go 4, but no, because it's the hypotenuse, okay? So be careful with that. All right, just a warning. This guy right here, what quadrant is he in?
Second.
Second. So let's put him there. This is V. His cosine, what's cosine? What over what?
A over H. X
Yeah,
over R.
adjacent over hypotenuse, or x over r, whichever way you want to see it. You know r, or the hypotenuse, cannot be negative, so that's 13. So this has to be a negative 12. Anybody know what this side is?
5.
Yes. It's this squared is 169. This squared is 144.
That's
169 minus 144 is 25, so its square root is 5. And it is positive, it's going up. Okay? So now all I'm going to do is I'm going to expand this. Alright? I'm going to use my formula card. Although the sine ones are easy. Okay? They go sine, cosine, cosine, sine, and it keeps the sine of this middle guy. It's the cosine ones I always get mixed up. Alright, so this should be the sine of u, the cosine of v, plus the cosine of u times the sine of v. You agree? I just read it off my card right here. Sine u cosine v plus cosine u sine v. Alright, anybody got a question? Alright, let's plug in our stuff. Here we go. So, sine of u. Here's u, guys. His sine is opposite over hypotenuse.
4/5.
4/5. And that's what it told us it was. We're so smart. 4/5. Cosine of v. Here's v. Adjacent over hypotenuse,
-12.
-12/13.
It gave us that one.
Oh, we are on this. We are so good. All right. Cosine of u. Oh, I gotta go up here. I gotta do the cosine. 3/5. Adjacent over hypotenuse. Sine of v. Gotta go down here to v. I want the sine. 5/13. How do you multiply fractions?
5 times 5, 5.
Very good. Can't reduce anything. All right, and I want to be really careful reducing because right now, will I have a common denominator?
Yes.
Okay, so be careful with
But
that.
I mean, you could reduce those 5s, huh?
Yeah, but hang on just a sec. So this becomes -48. 5 times 13 is 65. Are you with me? Plus, do we want to reduce these 5s right here?
No.
Wow, what happens
Because we
when you
won't
do
have a common denominator.
Yeah, then you won't have a common denominator, and guess what you'll have to do?
Find one.
Multiply by 5s to make one. Okay? So don't be careful doing stuff like that. So 3 times 5 is 15, and 5 times 13 is 65. That's a -48 65ths plus 15 65ths.
-33.
Perfect. All right, anybody got a question? All right, are these bad?
Yes.
Was.
These aren't bad, guys. Like you got a card. You know what would be bad? If I said you can't use this card on the test.
I still wouldn't.
That would be bad. All right, so here we go. This is example 4. And here's what it says. Write cosine of the arctan of 1.
We can't see.
Oh, sorry.
It's all yours.
Cosine of the arctan of 1 plus the arc cosine of x as an algebraic
I don't like that word.
Yes.
I feel really
Hurt.
expression. Write that as an algebraic expression. So these directions are different than what we've been doing, aren't they?
I don't see our
Those
cosine on my
Those
card.
directions said find the exact value. Find. Okay? This says write it as an algebraic expression. What does algebraic mean?
No equal sign.
That's what expression means. What does an algebraic mean?
X or Y.
Yeah, it's gonna have a variable in it,
Right.
guys. Okay? Gonna have a variable in it. Oh my word, y'all scare me sometimes.
Wait, expression, that means no equal sign.
No equal sign. Alright, so that's why we can't solve it, because look, there's not an equal sign anywhere. Alright, so here we go. Shh. Here we go. These have been angles, do you agree?
Yes, ma'am.
This is an angle. This is the angle whose tangent is 1. What angle would that be?
Poverty.
Yes, I'm gonna go 45, just because I like degrees better. And you are more comfortable with them, most of you. Some of you are radian people, you don't care. Alright, what about this guy? The angle whose cosine is x.
Oh, we don't know.
We don't know, we don't know. But if we, do you agree that this?
Cosine of 45, never mind, I know this.
Okay, so let's say that this is v. Do you agree?
Okay.
Does this look like this? The cosine of 45 plus v. Do you have a formula on your formula card for that?
Yes,
Okay,
probably.
so when I do this v, do I know the cosine of v?
Yeah.
What is it?
X.
X. Okay, but aren't we gonna have to use the sine of v also? So we need to go over here and figure it out, just like we did those other ones over there.
Wait, but how do you know it's not a U? Is it because is it the first one always a U?
Yeah.
And the second was always
It's
a
u plus v or u minus v.
Gotcha.
Alright, So let's do this one. Let's put him up here. He is V. And his cosine is x over 1. So cosine is adjacent over hypotenuse. So this is x and this is 1. Have you had a problem like this before?
Yeah.
Yes, you have. It was on a worksheet. Okay, so if you copied it and got the answer from someone else, here you go. It's fixing to bite you again. All right, so let's call this A right here. Do you agree that A squared plus B squared equals C squared?
Yes.
Are you with me? So I'm going to say A squared plus X squared equals 1 squared. Are you okay? All right, so I'm going to solve for A. So A squared is equal to 1 squared is 1, right? So 1 minus X squared. Now what do? What's the square root of A squared? So this is what that side is equal to. Can I separate those and say the square root of 1 is 1 and the square root of X squared is X and say 1 minus X? No. When is the only time you can separate things under a radical? If they are what? Multiplied. Not added or subtracted. Okay? So let me show you a trick sometimes. Because sometimes when you look at that on a test and you go, can I do that or can I not? Because y'all listen to me. If you remember that other worksheet, it was multiple choice and one of the answers had 1 minus X. Like they had done that. They know what kids are going to do. Okay? So here's what I'm going to do. I'm going to make up some numbers and see if it works. Am I going to be very specific in what numbers I make up? I am, because I don't want to have to pull my calculator out. I just want to do it in my head.
Oh, it's 'cause we
Okay?
know it.
So I'm going to do 25 minus 9.
Wait, so you're
Why
just
did you do
making
that?
up
I'm just making up numbers.
to find
Now, what is 25 minus 9? 16.
That's 4.
So this is actually equal to the square root of 16. Do y'all agree with that?
Yeah.
What is the square root of 16?
4.
4. Well, let's see if you can do what y'all want to do. Separate them. What's the square root of 25?
5.
Minus, what's the square root of 9?
3. But now, when you subtract them, then you have to square root it because you separated it, or you have to square it. So
No,
then it's gonna be 4.
no, no. I don't know if he is or not, but don't be saying stuff like that because you don't know what you're talking about. Here's the thing, is 5 minus 3 equal to 4?
No.
You cannot do that, people. You cannot do it. You can't just take that number and do what Colton was doing and do all kinds of weird things with it to make it be that, oh, you can add 25 and then subtract 36 and then divide by 4 and then multiply by 2 and then I end up with a 4. No, people, no, you can't do that. All right? So, this side right here is the square root of 1 minus X squared. All right, you with me?
No, wait, what is it?
The square, it's this right here. The square root of 1 minus X squared. That's what A is. All right, so now I'm going to expand this guy right here. All right, he's a cosine something plus something. Here he is right there. So it's going to be cosine of the first, cosine of the second. This one switches the sign, so it's minus sine of the first, sine of the second. All right, so he's going to be the cosine of 45 times the cosine of V minus the sine of 45 times the sine of V. Are you with me? Yes? All right, what's the cosine of 45?
2 over square root of 2 over 2.
Square root of 2 over 2. Times, what's the cosine of V? Go over here, guys, and look. Adjacent over hypotenuse. X over 1 is what?
X.
X. Minus, what's the sine of 45?
Square root of 2 over 2.
Times, what's the sine of V? Sine of V is
Square root of 1 minus X
opposite
squared.
of our hypotenuse. So the square root of 1 minus X squared.
Yeah.
Okay? Now I'm going to show you, this is going to look weird, all right? So over here, I'm going to put this guy over 1, and I'm going to get, you can write it whichever way you want to. If you write it like this, you make sure that that square root symbol does not go over that X. Do you understand?
Oh, I don't trust it.
Okay? So if you don't trust it, you can write it like this.
Oh, okay.
Minus, over here, it's all over 2 again. Can I multiply these two things?
No.
No. So the square root of 2 times the square root of 1 minus X squared. So my answer is, I can multiply those. I could say the square root of 2 minus 2x squared.
Can we not?
What? It doesn't matter. I don't care if you do it or if you don't. It doesn't matter to me. I mean, either way, it looks kind of nasty anyway. So either way you wanted to write it, I'm okay with it. Okay? I mean, obviously you can, if they're both under a radical and the index number is the same, you can
Ms.
multiply
Davis, why
together.
do you do this? So like, you see how like, all your 2's are the same, right?
Well, no, not all of them.
Except that one.
No, not even that one. Look at the other one, right there, and then look at the one over there, under the square root 2x.
That one.
Why are they different? Why
I
do
don't
you do that?
know, because when I get in a hurry, I just do it looks like a Z, that's why I always put a line from a Z. All right, here we go, moving on, example 5.
What?
Example 5, here we go.
We're done?
Yep. That's it, that's the answer, that's what they asked for. Well, they asked me to write it as an algebraic expression,
Yeah.
and that's as simplified as it gets, you can't collect any of that mess.
Alright.
Okay? So, here we go. I want to do the cosine of pi over 2 minus x is equal to the sine of x. And they asked me to prove it. Prove it. Okay, so this is kind of like a trig identity, right? Do you understand? Kind of like a trig identity. Which side am I going to work on? The left. Okay? Do you have a formula from your formula card that looks like this? The cosine of something minus something. Alright? So it's going to be cosine of the first, cosine of the second, plus sine the first, sine of the second. Are you with me? So I'm going to rewrite it. Now y'all listen to me. Do I know what's fixing to happen?
Yes.
No, I don't.
You do.
That's the only thing that I can do with this thing. So I do it, and I just go, well, please Lord, help it work out right. So, cosine pi over 2, cosine x, plus sine pi over 2, sine x. Alright, so pi over 2, that's a quadrant angle. Are you with me? It's this quadrant angle right here, guys.
0.
0, 1 is the point. Okay? Cosine is the x value. What's the x value?
0.
0. So it's 0 times the cosine of x. Y'all can't do anything with the cosine of x, okay? So plus, what's the sine of pi over 2?
1.
1 times the sine of x. What happens to that first term? What? What do you mean you don't know? What's
Is it
0
zero?
times anything?
0.
So it goes away.
So it's just sine?
So that goes away, and here I'm left with 1 times sine x, which is what?
Oh, just sine x equals sine.
What? Look at there.
I'm
I
not
like
trying
that
to-
one.
I'm
That-
Beautiful.
I like that.
Beautiful.
That
That's
was-
those trig identities. I love, this is not actually a trig identity, but it's using the same kind of skill.
This one, I made it out.
Alright, here we go. Are you ready?
Wait,
Example 6.
How do we prove that?
You just did. You make one side equal the other side.
This one's gonna be one.
No, because I'm gonna fit 2 on, down here. I have this much paper left and I'm fitting 2. Alright, so here we go. 6a, the cosine of theta minus 3 pi over 2. All they asked me to do is simplify. Okay? Now y'all listen to me. Directions are really important. They're giving you clues. Am I going to find a nice pretty little answer like the square root of 6 minus the square root of 2 over 4?
No.
No. It says simplify. It didn't say find or evaluate. Alright? Yes.
Why do you always write the lowercase theta?
Because that's what they always use in trig.
Okay, because now that I know uppercase theta, I was like, oh my goodness, why is she?
You don't need to know uppercase
You
theta.
only know the check mark ones.
Dog.
You were probably talking when we said that about 5
Cole,
times, but
I asked you this morning
It's
if
okay.
you studied, you said no, so.
Well, he always
I
be lying
knew
when
all
we
of
ask.
them.
hey, I don't have time. Let's go. So expand this right now. You got 30 seconds. Go. Expand it. Use your formula card. Colton, this is why you're getting behind.
I know, I just gotta prove Travis wrong.
I'm already.
Shoot, so
Okay, so this is what you should have gotten. Cosine theta, cosine 3 pi over 2. Change the sign. On the cosine, he changes signs. Plus sine theta, sine 3 pi over 2. 3 pi over 2, what kind of angle is that? That's a quadrant angle, people.
Yes.
He's right down here. He's right down here. It's 270. He is 0, negative 1. Okay? Are you with me? Cosine theta times, what's the cosine of 3 pi over 2? 0. Cosine is x. Sine is y. Plus the sine of theta times what's the sine of 3 pi over 2? Negative 1. Okay? This goes away. And negative 1 times sine theta? Negative sine theta. Beautiful. That's simplified. You with me?
Do we have another one?
Yep, we're gonna do one more. Actually, we're doing more than one more. We almost got as far as the other class, we're going to. So, the tangent of theta plus 3 pi. Simplify. Simplify. That means we're using the tangent one. Here's the adding, and here's the subtracting. We're using the top one. So this is my formula right here. Alright? It's equal to the tangent of the first, so that's going to be tan theta, plus the tangent of the second, the tangent of 3 pi, over 1 minus tan theta, tan 3 pi. Okay, so we can't do anything with tan theta. Do you agree? Y'all, it's proper to work fractions down your page, but because I don't have lines on mine, it makes it difficult sometimes for people to read my notes, so I go across. So tan theta plus 3 pi is the same thing as what? Pi. Yep. Here is, look, here is 2 pi, 3 pi. So here I am right here. I'm in a quadrant angle again, negative 1, 0. Those are my points. So tangent is y over x. What's 0 over negative 1? 0. Over 1 minus tan theta times, what's tan of 3 pi? 0. On the top, what do you get? Tan theta. On the bottom, y'all, this is 0. What's 1 minus 0? Okay? All right. Here's your last one.
Ms. Davis, I have been studying all of these.
Write this down. Well, you ought to be good when you knock off the ones you don't have to know.
Can I
Write
write all
this
of
down.
them?
Shh. Write this down and do it as far as you can do it. Okay? If you can solve it all the way out, I'm good. You should know. If not, we'll talk about it tomorrow before our test, and then I'll give you your test. You do have a test tomorrow on the on the Greek alphabet. Yes.
So if it is it, are they all in order? Like it's the order of the alphabet, and then you have the blanks for upper and lower.
There's your test.
Oh yeah, so they are in order.
Sure.
No.
Be neat or be wrong.
Be neat or be wrong. That means if you like go, I don't know, some kind of curly thing with some kind of, and you can make some
There's
scribble
one
scribble
of
on your
them that-
paper.
there's
One
one
of
of
them I don't know how to write.
It's like a backwards 3 or something.
No,
No,
it's
it's-
like a cursive E with the little
Look.
swirl on the top of it.
It's
Swirl on the
this
bottom.
It's this one, huh?
Yeah.
It looked like a little piggy. That's a little piggy too.
Yeah, I don't know how to.
Yeah, you
Oh, I
would.
know, it looks like a
Will you get the gist?
You guys could list like that. All right, I'm stopping this. We're gonna do this problem tomorrow.
Ms. Davis, I was dying earlier because